started. Hi. I'm Noel Rappin. Testing should be fun. That's it. Thanks. Okay, that's tempting, but I'm not going to do that. I work at Group-on Engineering, where we have a lot of really smart engineers doing a lot of cool things. If you'd like to be one of them, we are hiring in Chicago, Palo Alto, Seattle, and possibly other locations as well. You can come see me at some point today, or go to groupon.com/techjobs. That's the end of that infomercial. I'm also at Noel Rapp on Twitter, should you feel like communicating with me over there. Okay. I want to talk about testing today a little bit, obviously, and I want to start with a little bit of a quiz. Who's this guy? Kent Beck. Somebody got really quick. Yes, Kent Beck. Okay, why am I showing Kent Beck here? Anybody? Yeah, so Kent was, if not the inventor of test for the test first style, certainly a very strong popularizer of it. In particular, Kent wrote this article in 1998. This is one of the things where I'm starting from here. If you can't read it, it says, JUnit test infected, programmers love writing tests. If you're looking for this and you are kind of an archaeological fan, this is still living at sourceforge.net, junit.sourceforge.net. And as you can tell, the HTML style has not been updated really since 1998. If you can't read the internal paragraph there, it says, testing is not closely integrated with development. This prevents you from measuring the progress of development. You can't tell when something starts working or when something stops working. Using JUnit, you can cheaply and incrementally build a test suite that will help you measure your progress, spot unintended side effects, and focus your development efforts. So that's very much the same pitch that is still being made for test first programming 14 years later. Two things that are interesting about this article, looking back on it. One is if you go in and read it, and you probably should, is that Beck here is not really talking about what we would consider test first yet. He's talking about incremental testing, but he's actually writing it up as code a little, test a little, code a little, test a little. He hasn't gotten to the insight yet that the tests might be better off coming first. And the other thing is this idea that programmers love writing tests, and that programmers would, left on their own, really love doing it. And I really took to this. Maybe I'm just easily suggestible, but I started using JUnit, and I really enjoyed it. How many people know what this is? Show of hands. Anybody want to shout out? Huh? I can't hear you if you don't say anything. This is the JUnit test runner circa 2001 or something like that. This was my RSpec in 2001. And I actually had, when I was searching for this image to find it, because you can't really, I don't think you can, this is the runnable interface anymore. I had a really warm wave of nostalgia when I saw it. Like, I used this interface for a long time, and I really associated it with doing things well and being, enjoying the things that I was doing. Okay. So who's this? I think you got it now. Okay, thank you. Abdi Grimm. Notable for many things, the one I want to talk about right now is a talk that he gave almost exactly 1 year ago called Confident Ruby at Ruby Midwest. It's available online. I recommend it. Abdi said something interesting at the beginning of the talk, that really resonated with me. The talk is largely about using good programming practice to improve sort of at a micro level your Ruby code. But one thing he said right at the top, he said, I used to think this talk was about programming, but now I see that this talk is fundamentally about joy. And it occurred to me, it has occurred to me, that the programmers love writing tests that Kent is talking about, and this talk is fundamentally about joy that Abdi is talking about, are very similar, if not actually the same thing. It's the satisfaction, maybe satisfaction is not a strong enough word, but it's what we get when we feel like we're doing when we're coding well. I was going to say do our jobs well, but I think it goes beyond doing our job. I think that many of us are here, especially many of us are here, because this is something that we enjoy doing and that we enjoy doing well. But I also work with a lot of people and talk to a lot of people who complain about their test suite and that having to write tests first, not necessarily having to write tests first, but that the tests are buggy, they're long, they're slow, they're a pain in the neck.
How many people feel that way about something that they have work on or work near, that the testing has become a burden? Probably that is why you are in this room right now, I hope. If you think you're, yeah, this is not the game programming talk if you haven't figured that out yet. So the question is do we still love writing tests? The Ruby community really has a test culture in a way that other programming communities don't. But do we still love it? Or, like a lot of novice writers, do we just love having the test written? Or, like a lot of the hipster stereotype of Ruby programmers, do we just love saying that we've written tests? And what is it that makes testing fun? And fun may not be the best word here. Maybe it's satisfying, enjoyable, useful. But that feeling, what in it in tests, what brings us that? And I want to suggest that there are two separate pieces to that, and then I'm going to expand on that idea a little bit. I'm going to throw two words up here that are somewhat synonyms, but I'm going to be using them to reflect different aspects of the testing experience that I can think of as the short term and the long term. In the short term, what's enjoyable to me about TDD is the idea of feedback. You have this idea that I have an immediate sense not only of what my code is doing, but what I'm going to do next and whether what I just did worked. And there's a very strong game relationship to this. I've set myself a small puzzle to solve. I solve it. Yay. I mean, the positive feedback cycle of that is very enjoyable and a little bit addictive, perhaps. But that's the short term. That's what happens as you are building your tests. But there's also a long-term aspect to it that sometimes I'm calling communication. And this is what your test suite potentially brings to you as it continues on. Because the tests that you write in a TDD process don't vanish into the ether once your feature is done. They live in the test suite. And a lot of what I'm going to talk about here for the next 35 minutes or so is going to be focused on the implications of that these tests live on forever. And there's a communication aspect to that, some of which is that the tests somewhat serve as documentation, some of which is that the tests serve as a marker of your intent, some of which is that the tests serve to communicate whether everything you think the test is doing still works. But this is obviously, this long-term signal that you get from a good test suite is obviously, to me, part of what makes this process valuable, fun, whatever. We can look at this from the other side, too. What makes this not painful? What makes us dread going into our spec? What makes us dread typing spec at a command line? And there are a couple of things like this. Long run times are a big one. Tests that are flaky, intermittent failures. Intermittent failures are really morale sapping, I think. Tests that are impenetrable, you don't know what there is. You're afraid to look at the test from 6 months ago because you don't know what they're doing and you don't know even whether they're still needed. All of this stuff is kind of a drag on your own work. I'm kind of building up towards saying productivity, but that's not really what I mean. It's just sort of a drag on the way that you can bring this test-driven process to bear. And I think some of this can just be summarized that as test suites get big, they become unwieldy. And I think that as a community, we haven't really solved that problem of how to deal with a test suite as it goes from the thing I do to solve this immediate problem to the thing that is an artifact of my code, just like my application is an artifact of my code. Or look at it this way. From my perspective, the TDD process is red, green, refactor, and I move on. The test fails, the test passes, I clean up my code, and then I'm on to the next test. From the perspective of the test, the process looks like this. Red, green, refactor. Green, 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 green. The test continues to run, right? And this is the best case. I thought about sneaking in a red there in the middle there. But I'm sure all of us, none of us writes that kind of intermittent test that would just fail once every 12 times or something like that. No, of course not. Not you, not me, not you. Tests are run way more often than they're written. This is a weird kind of pseudo-analogy to the idea that code is read more often than it's written. Tests are run more often than they're written. At Groupon, we run our continuous integration server on a build farm that is probably, and I say this not as a point of pride necessarily, we run it on a CI server that is probably more powerful than many of your production web servers. And that's in the service of getting our test suite down to a mere 20 minutes on all that hardware. Nobody knows what the entire test suite runs at on a laptop because nobody runs it on a laptop because it's infinite. Who knows? Could be. I don't know. That continuous integration server runs upwards of 100 times a day. And that doesn't even count the number of times that a developer will run part of the test suite as they're building something. So we have tests that run, that are individually run. I mean, obviously, this is a point. Our production code obviously gets run more often than our tests. But we spend a lot of time thinking about how to make our production code faster and more efficient. Our tests get run over and over again, but we don't necessarily spend a lot of time thinking about the implications of that. What does it mean when you add an extra test? When you write a new test, you're living with it potentially for the rest of your product's life cycle. You're adding time. You're potentially adding something else that somebody else needs to understand. You're adding another point of failure. I am not in any of this saying that you should abandon TDD. TDD, test first, BDD, whatever you call it, has been the focus of how I've arranged my professional work for over a decade. I love it. I think it's a great process. I'm not saying that you should abandon it. I am saying, though, that the way that we do it right now tends to break down over time, and that we could probably think, there are probably ways that we can do this that will make this more pleasant, more fun. Tests can be legacy, I think, is one of the points. Michael Feathers writes in the Working Effectively with Legacy code book that was written in 2004, he defines legacy code as code that doesn't have tests. And I think 8 years on, that seems kind of quaint. The idea that you could have legacy code, the idea that tests in and of themselves would keep code from feeling like legacy code seems like an artifact of a time when there weren't very many people doing test-driven development. Because I don't know about you, but I have seen and worked with code bases that have full test suites but still have the kind of legacy feel in terms of being resistant to change. Some of you are nodding. I think that might include some of you in the audience. I kind of call this the uncanny testing valley. You reach this point where you're committed to testing and you have put so many resources into testing that you feel like you need to continue to put all of these resources into testing because you're doing it, but yet you don't have enough tests, or your tests aren't good enough for you to be confident when you make large changes. So you kind of have the worst of both worlds. You have the cost of maintaining a large and somewhat flaky test cycle, but you don't get the benefits of feeling like you can make changes with confidence. Details matter here when you're making tests, when you're writing tests. Things that seem like small details when you're writing tests, in much the same way that many of us have embraced, maybe all of us, have embraced this idea when it comes to our code. We've embraced the idea that small details matter in the long-term maintainability of our code and the long-term suitability of that. I think that to a large extent, we need to embrace that mentality when it comes to our tests, too. Tests are a part of our code base. In fact, it's even more imperative that our tests get written well because our tests are part of our code base, but our tests don't have their own tests. If our tests are bad or fail or hard to read, we don't have a level underneath us, thank God, because otherwise we would be coding in an Escher painting. But we don't have a layer underneath that to catch that if we make a mistake in our tests. So it's imperative that our tests are as clean and as clear as we can make them. one of the things, to me, the higher order principle behind a lot of what was XP, and we now kind of group into Agile, the name Agile, is the idea that things that are complicated and take a large amount of time and have high risk, we can mitigate that by doing them continuously in small pieces. So testing is hard. We do test-first development, so we build our test incrementally over time in small pieces. Integration is hard, so we can integrate continuously. I assume that almost all of us work in a project where it is part of our project's culture that people move their code back to a common code base daily, if not more frequently. That is a staggeringly new idea. 10 or 15 years ago, that was crazy. That was just something that you couldn't do. Code review is hard, so we pair program, which is effectively continuous code review. Refactoring is hard, so we do it in pieces at the end of every code cycle. And I think what I'm suggesting here is that part of this cycle, part of this refactoring cycle also includes the idea that tests are code that needs to be refactored. And I want to suggest some possible individual refactoring, so I am going to show some code. Yay. I want to suggest some things that are possible test refactorings. Part of this is because I think that these things are good ideas, and I see tests that don't do them. Part of it is I want to kind of start the idea of there being a vocabulary around these kinds of refactorings the way we have built a vocabulary around regular refactorings. And part of this is just to hopefully put the thought in all of your heads that looking at your tests with this kind of refactoring eye is also a valuable use of your time. Okay. I also think, to start off here, that even if you're not using Cucumber, or even if you're not using RSpec given or something like that, the structure of a test, thinking about the structure of your test as having a given when then structure is valuable. There's a benefit to you to thinking about your test in terms of first part is a given part where we gather some data, second part is a when part, we do something in the program, and the third part is a then part, we evaluate that. That's a rhythm or a structure that is very adaptable to most of the tests that you're going to write. And if your tests seem to be abandoning this structure for one reason or another, there's probably a better way to do it. So, and then also some of these suggestions that I'm going to have here come on the setup side, and a couple of things to think about when you're actually running your tests as well. Okay. In setup, one refactoring that I think is useful is applying a behavioral name to your tests. And in general, thinking a little bit about the naming of your tests. Naming tests is sort of in the same category as general documentation or commit messages. We all know we should do a better job of it than we actually do, and we never quite get the feeling that we've done a better, that we never quite work up the energy to actually do that better job. But we wind up then with, here's one kind of bad case here. The test names are here kind of lazy. It handles true input, it handles false input. This provides no information about my intent, about what's actually happening here, and it makes the test very hard to keep up over a long time when someone else comes to this and needs to figure out what's going on. It's a little bit better, but not ideal, to structure this by method. You see this quite a bit. In this case, the outer describe block is the method name, potentially, and then the inside block is describing how that method acts. We're describing this in terms of the internal implementation of this in my actual code. In its own weird way, that's a dependency. This test the test name is sort of dependent on the structure of the method and the structure of these pieces remaining the same. If that changes, but we don't change the code name, the test name, then we're confusing future developers. And in this case, for future developer, you should, as always, read you in 6 months. That's if you don't have empathy for other people. At least have empathy for yourself in the future. What? Right. Yes. Yeah. I mean, the assumption here, if the method. So the question was, if if the test is named after the method name, would you assume that that method is called, and that if the method name changes, that it would break? Yes, that's hopefully, ideally. Explicit breakage is always a good idea. But I prefer describing the test in terms of the behavior they're trying to get. I mean, really, the B in behavior-driven development doesn't just mean that we use it and should and describe instead of assert. What it means is that we think about what we're doing, describing what we're doing, in terms of the behavior that we're expecting and not the implementation of it. So in this case, I'm describing when checking for validations, and I'm saying it allows an admin user access, it denies a regular user access. It's generally a good idea in the test name to describe what the test is actually doing and what the expected behavior of the test is. And one reason for that is 6 months from now when the test fails, not if the test fails, when the test fails, and somebody, because there's been another change in the code, and somebody has to decide, is the test right or is the code right? The name of the test provides a hint as to the intent and gives somebody a clue as to whether they need to change the test to conform to the new code or whether you've introduced a bug. Another refactoring here is extract test, splitting a long test into 2 smaller tests. So here's a sample test. This is a relatively non-egregious version of this, but I'm creating a user. I'm creating, for example, a blog post, testing that a user should have visibility to the post, changing the role of the user, testing it again, changing the post, testing it again. This is, to my mind, if you think about this in terms of a given when then structure, what this test is doing is I'm doing a given where I'm gathering data. I'm sort of doing a then. There isn't really an action here except the association, I guess, is implicitly an action. I'm doing a then to test something. And then I'm gathering more data, and I'm doing the then again, and then I'm gathering more data, and I'm doing the then again. It's not horrible. I think almost everybody here can figure out what this is doing. But it does separate 3 different concerns here, 3 different logical concerns in a way that makes it hard to tell later on when the test fails what's accurate. And so I would recommend, this was part of how I would recommend changing it, 1 test at a time. Not necessarily, we'll talk a little bit more about single assertion style in a few minutes, but here we have 2 separate givens and then 2 separate thens at the end. And now it's 2 different tests, each of which has its own intention name. And this is, over time, a little bit easier to deal with. Now, there's a slight performance cost, and we'll talk about that a little bit too. And one of the things here is, sorry. The next thing, and a lot of time, as in other code situations, creating one refactoring makes the underlying structure visible to see what the next refactoring is. And in this case, it makes it very clear that we also have a common setup that we can extract out into moving from a duplicate setup in multiple methods, moving to a before structure in our spec or a let structure in our spec, which will both do the same way, both have the same effect. And in this case, we have a common setup. There's some good and bad in this, as in a lot of refactoring. Sometimes there's a trade-off in terms of what is an improvement and what's not an improvement. To my mind, one of the improvements of this is it makes it explicitly visible. It separates the important part of the test itself in the it blocks from the setup in a way that makes it easy to see what parts of this are setup and what parts of this are actual logic. There is a danger if you make the setup, if the setup is in such a way that the setup gets kind of far away from the actual code, then the test kind of feels like magic. This is a problem, one of the problems with global fixtures with a lot of explicit data. You get tests that just say, oh, this should be 47. Why? Well, because there's data that you can't see in another file that says that this answer should be 47. So you do need to be aware of that. But in general, it's a good idea to factor out common setups for the same reason it's a good idea to factor out in regular code. When you're gathering the data, a really important kind of refactoring is to remove or not create extraneous objects. So here's a test we're determining whether or not we can extract users with high ratings on some kind of 1 to 10 scale. And we're actually explicitly creating 10 users here. A user with each individual rating, and then we're checking that the 2 users with high ratings are the ones that we find. The problem here is that we are creating 10 users. In worse, we're saving them all to the database. In fact, we don't need to create 10 users to drive this. So we're reaching a little bit of a distinction here between the purpose of a test in a TDD environment to drive the code that we're looking at, and the purpose of a test may be to perfectly 100% verify the behavior. This is creating too many objects in a TDD setup to drive this test. And that's going to slow things down. And slowing things down by the amount of creating 8 extra objects in the database, which doesn't seem much when you have 1 test and you're running it once, but seems like quite a bit when you have 1,000 tests like this and you're running it 150 times a day. That's where you get to the point where you have to give everybody a week off to clean up, to find the fastest tests and clean them up. So one solution here is create just enough objects. Usually just enough objects to manage your boundary conditions. If you have more than 1 boundary condition, that implies that you need more than 1 test. In this case, we're creating the low user and the high user, which are just at my presumed boundary of what a high rating should be. And so I'm testing that I just get the high one. If I find a bug in this because my boundary condition is incorrect, then I write another test. I don't try to solve all the problems in the world in 1 test. This brings us to another somewhat related issue, which is to remove database creation. Those of us who work in Rails all the time have sort of implicitly been allowed to buy into the idea that you can call something a unit test when it hits the database, which is a fairly large third-party dependency on something that is nominally a unit. But Rails makes it real easy to do, so we do it, because it's really easy, and it's sometimes valuable. You really, really shouldn't hit the database in a unit test. If you feel like you need to hit the database in a unit test, that probably means that the structure of your code could stand to be improved. So we have an unnecessary database hit here. I'm creating 2 users and I'm saving them to the database, but there's nothing in the rest of the test that needs those things to be persisted. So we can just change those to user new. We're not getting a database hit. And this is actually, even with 2 objects, you can often measure the difference, the speed difference on a single test for that. So let's take the same test and see how it works a few months later. We've added some validations to the user object, and now suddenly, in order to create these simple user objects, we need to make them pass the validations. And now we've had to add a password and a password confirmation and a username and an email, because user objects need to have those things. Otherwise, we get validation failures. So in this case, we might not, because we're just creating them and not saving them. But the problem here is we now have introduced a lot of noise in this test. It is much, much harder to look at this test and see what the important piece of data is. The important piece of data here is that the high user has a rating of 9 and the low user has a rating of 8. But that's completely swamped by the amount of data. For me, this is the use case for factories. For me, the use of a factory is somebody like that, okay. For me, the use case of a factory, and global fixtures can solve the same problem. As long as you're careful, both of these can solve the problems. You need to be careful with how you use them. But the use of a factory here is to create a default object such that when you need to have one of those objects in your test, you can explicitly specify only the attributes of that object that need to change that are valuable for the test. So we're back to being able to easily see that one user has a rating of 9 and the other user has a rating of 8. And this test is much, much easier to understand. Where you get in trouble with factories is where you use them to specify chains of association, which you absolutely should not do. You should never, my opinion, use factory girls association stuff to automatically create associations. If you need an association for a specific test, you should create the association in the test. If you don't do that, you wind up being in the situation where you create one object for a test using a factory, and you get like 20 or 25 other objects on an object tree coming along with it, all getting saved to the database. And not for nothing, but removing that was how we got the Groupon main web app code test suite down from 40 minutes to 20 minutes because there had been so much of that kind of factory usage. Where you get in trouble with fixtures is where you depend on specific pieces of the data that are hidden in the fixtures. You go, I'm going to grab Fred, and I know Fred is 6 feet tall because in the fixture file it says Fred is 6 feet tall. That's where that gets in trouble. That becomes hard to see. And I had a project a long time ago where we had all these tests for a search function that depended on a particular universe of objects being in the fixture files, and somebody would add a new fixture and suddenly 25 search tests would break. That's bad. Don't do that. This is sort of similar to, this is the Cucumber version of this. The Cucumber version of extracting tests. Here we have sort of a workflow in Cucumber. It's a little bit easier to see why you might want to do this in Cucumber than in RSpec, but I still think it's kind of a bad idea. I still prefer to try and do this in separate pieces and build up a chain of smaller tests to test my workflow. Except in some cases, unless there's like a super legitimate need to test the entire workflow as one unit and test individual pieces along the way, I'm not a big fan of doing that, of trying to do multiple hits in one test. I also recommend you invoke your actions at the right level, which is another way of saying that Cucumber makes a lousy unit test framework. My opinion of Cucumber here is Cucumber is a very good way to focus your happy path development, know what you need to do next, and most importantly, know when you're done. Cucumber is not a great way to unit test individual behavior of individual methods. And if you find your Cucumber tests in particular that you are writing a lot of them, and they become a real burden on it, you should really take a look and see if you're testing things in Cucumber that probably could be better tested in a more focused way by unit testing a controller or unit testing a model. Single assertion as a test style. So here, this is a test written as single assertion. The idea behind single assertion is that, like in an RSpec sense, the idea is that in a single assertion test, you put the given and the when in your before block, and you only put the then in your if block, and you only have one per if block. So if you look at this test, I have a common describe block, a common suite. I have a given where I'm grabbing a user and giving their deals for, and I'm adding a deals type being restaurant, and then I have individual assertions on the different pieces of that. Alternately, I can write this as a single test where the given, the when, and both thens are in the same test. And you'll see arguments either way on this. The single assertion tests have the advantage that they can fail independently, and you can give them independent intention revealing names, and that's an advantage. On the other hand, they're often slower. You're doing the setup multiple times, so if you're doing a complicated setup, they're often slower. I don't have a 100% recommendation on this. I tend to prefer single assertion, but if I have two assertions that are very, very tightly coupled for some reason, and I don't expect them to ever fail separately, I will often put them in the same test as much as anything else as a marker for my intention that those two assertions are very tightly coupled. You should also make sure you're testing the thing at the right level, or testing the thing that's actually part of the class that you're dealing with. See this a lot in Rails controller tests as maybe the most obvious example. Here's a controller test where I'm creating two users, I'm running my search, and I'm determining that the search returns a particular object. That's not really a controller test, although I would imagine that everybody in here who's done Rails has written a test like this. I certainly have. This is really a model test. What I'm really testing is that the behavior of the models, the behavior of the model's search method. From the controller's point of view, the only thing we care about is that we call the search method. And that's a common thing when you have code that integrates multiple layers of your program. You want to make sure that the tests are isolated as much as the code is isolated. That when you are boundary testing over a level, that's a really good place to have a stub or a mock. The problem here is that if your tests cross, the problem here is very similar to regular code. If your tests cross a layer, you have the same dependency problems that you're going to have if your code crosses a layer, which is that your test becomes brittle against changes in the code. And it also, because we frequently will also have a model test that tests the search, you have some duplicate tests, and that's going to slow things down. Again, a lot of this stuff sort of becomes visible statistically once you have a large test suite, and there are things that you can get by with when you have a small test suite. But again, as with regular code, the boundary here is you don't always realize that you don't realize that you are coming up to the boundary of when you need these complexity measures until you've already passed it. You don't realize that you need all these fancy techniques until you suddenly realize you needed them 6 months ago. And so you can help yourself. It costs a lot less to build these things in incrementally as you go. One tip that I like here is asserting against the primitive object. Here's the same search against the same test against the user. I'm creating two user objects. I'm doing my search. I'm testing the search against the actual active record object. And I don't always recommend that. And I often write this test where I test against a primitive, quote, primitive value, easy to print out value that comes from the object. So in this case, in the actual assertion, I'm mapping the list of results to their name and testing against the names. And the reason I do that is because it gives a much shorter, more concise error message when the test fails. If the test fails, then RSpec does not attempt to print out. In this case, if the test fails, RSpec will print out the entire active record object. And if you have a list of these things and you're trying to figure out which one isn't there, that's often a pain. In this case, if the test fails, RSpec will just give you the very short string. And that's much, much easier to deal with. That works for dates, too. A test against string versions of dates instead of date versions of dates. You will find that it is easier for you to mitigate against test failures. Your test failures will just be easier to read. I also prefer, this is a Jasmine example, I like the Jasmine structure of spies, not mocks. If you guys don't know the difference, a spy sort of separates into two steps what an RSpec or Mocha mock does in one step. In Jasmine, you do this in two steps. In one step, you use the spy-on function to say, this is a method we're looking at. And then later, you separately, and on the last line here, you separately check to see, use that spy to check and see whether the method has been called or not. And the reason, in RSpec, you would have a single line where you would say, at the top, you would say cheeseburger.cheeses should receive, cheeseburger.should receive cheeses. And that would stand to both be your indicator that you're interested in this method and also the expectation that the method is going to be called. And the reason why I don't like that at a little bit of scale is that some of it's philosophical. It breaks that given when then structure that I like, because we're specifying the data and specifying the assertion in the same line at the beginning of the test. Whereas in this case, we have a much cleaner line of responsibility. The top line is specifying gathering our data, including gathering that we're spying on this method. The middle line is doing an action, and the bottom line is making my testable assertion. And I find that to be much easier to read and to think about later on. Don't assert a magic literal. So here's a case where we have some code that's doing some math. We're doing some, this is actually all taken from a day-long TDD workshop that I do internally at Groupon. Deal's got a regular price, it's got a sales price, and the relevant score should be 42.5. Where does 42.5 come from? I have no idea. Looking at this test, I have absolutely no idea. It actually, the way that this happened, most likely, is that we said that it should equal nil. We got the test failure that said that it actually was 42.5. We plugged that value back in the test, which is a perfectly valid way to do like legacy testing. But it's not the best way to keep this going. And this is the other way to do it. And the other way to do it is to actually put your math in your test. And in this case, this is actually putting the arithmetic in the test. Now, I should say that the last time I gave this talk, I went back and forth onto which one of these was actually better. Since then, I actually was sort of incidentally flipping through the Kent-Beck test implementation patterns, and Kent-Beck, for better or for worse, explicitly endorses this second style on the grounds that once you have the test, you can actually take that bottom line of code and use it to build your implementation, which is fine, but I actually also think is one of the dangers of this, because if you actually copy this into your implementation and your math is wrong, then they're both wrong in the same way, and the test won't capture it. So if there's an advantage of actually just putting the final number in the test, the advantage is just that it lessens the possibility that the test and the code will be wrong in the same way, which is, take it from me, a very hard problem to track down. Also, complementary Boolean tests. Here, this is just an advisory. If you test the case, if you have a Boolean logic test and you test the case where it's true, also write a test for the case where it's false, just so you don't accidentally leave a tautology in there. Not that I've done that, except I have. It's just a good idea to get in that habit. When I write a test for the truth condition of something, write a test for the false condition of something, just as a matter of course. When you run your tests, you want to make it as easy as possible to run your tests, and that's going to mean different things for different people here. For some of you, that's going to mean mapping a command key to your text editor. For some of you, that's going to mean getting really good at the command line or building some tools to run specific test suites internally, building rake tasks or whatever. Within the Ruby tools that most of us probably use, both RSpec and Cucumber have relatively straightforward mechanisms for running individual files or individual tests or arbitrary groups of tests, which I recommend that you take advantage of, especially if you have a long test suite, so that you're only running the file or files that you care about. RSpec has a mechanism where you can only run, you only run files that have changed since your last Git commit, tests that apply to those files. That's also handy. Things like guard or auto test, if you get them set up right. I have kind of a love-hate relationship with them. Sometimes I really like them, and sometimes they irritate me. But that's a very frictionless way to run your tests, is to have them run automatically every time you save something. If you have never used guard or auto test, try it for like an hour, and just see if you like it. Also, you want to display. I'm not a huge fan of the typical RSpec .e .f display. I don't think that's tremendously valuable set of information. That said, the RSpec other default, the documentation default that lists all the nested code, that's a good thing to use sometimes. It's a good way to check your naming conventions. If you use that RSpec nested thing, you should be able to tell what all your tests are doing from that. It actually also noticeably slows down a test suite to use that suite. If you're interested in better ways to do this, there are a couple of RSpec formatters. One of them is called foobar, one of them is called 5mat. They both have kind of interesting, slightly more useful displays for RSpec code over time. So, I think what I want you to get in the habit of doing is listening to your tests the same way that you listen to your code. Like, the idea of test-driven development, the thing that truly makes something test-driven is that the tests are the source of truth. And if there is a problem writing the tests, your first assumption is that that indicates a problem in the structure of the code. But I think also we need to think about these sort of relatively simple ways that we can make it easier to write and to read and to run these tests over time. When you finish a feature, when you finish a bunch of tests, look back. Are all these tests still needed? I was here for Ben Orenstein's refactoring talk, and he said, what do developers love most? And everybody yelled out, delete code. Nobody loves deleting tests. Deleting tests is scary. Deleting tests has the risk of somebody coming over you and going, why did you delete that test? But That said, and this is like handing a very, very sharp knife to people, sometimes tests need to be deleted. If you are doing a normal TDD process, you will often start with some initializing structure tests that are just there to get your process going. A lot of times those tests are duplicate with later tests in that they will never fail independently of any other test. If you need to look, it is worth taking a little bit of time to look right there when you finish the little micro feature, which is when you will know as much as you will ever know about the structure of the test and the code that you just written. And look and say, is this test really independent? Is this test really going to, if this test fails, doesn't this mean that these other 5 tests are going to fail? And if so, do I still need it? Again, that is, I understand, it's dangerous. I am not saying go off and delete all your tests. I am saying, though, that it is possible that you have 5% of your tests you don't need or can't figure out. It's worth thinking about. Refactor your tests. Tests are code. Don't shortcut the process. Small steps, incremental steps. The more incremental steps you take, the smaller each individual step is, the more you are mitigating the risk of doing complicated things. The more you can break a complicated thing into simple pieces, the more resources you have when the actual complicated piece comes along. Avoid the uncanny testing valley. Make your tests things that you can be confident in. Developer testing, all of this stuff, is a means to an end. The end is being able to sustainably deliver features over time and sustainably improve your code. Doing this stuff well will make it, first of all, more fun to deal with your tests, but it will also make it easier for you to continue to sustainably improve your code. So that's what I've got. I'm Noel Rapp on Twitter. We're kind of low on time, but I'll hang around if people have questions. I'm Noel Rapp on Twitter. I have, if you liked hearing me talk, you might like reading things I've written. I have Rails Test Prescriptions, which is a couple years old, but still available from Pragmatic Programmers at pragprog.com. I also have this JavaScript book, Master Space and Time with JavaScript, which is self-published and you can get at noelrappin.com. And with that coupon code Ruby201225, you can get a 25% off the price of it today. Relevant to this discussion, it also talks a fair amount about how to use Jasmine to write good tests in a JavaScript environment. I work at Groupon Engineering. You can go to groupon.com/techjobs. I hope that's the URL. And I'm Noel Rapp on Twitter, and I'll be around if you guys want to say something. Thank you for your time and attention. I really appreciate it. I hope that you got something out of this.